Hello friends, today we will learn something about the electricity. This is the NCERT class 10th chapter number 12. Okay, electricity, just we'll learn the basic concept and we'll solve all the question of electricity. Okay, so what is electricity actually? We know everywhere we are using the electricity, okay, practically in the homes, schools, hospital, industries. So everywhere we are using the electricity on everyday life. Okay, so first we'll know the electric current and the circuit. Okay, so actually how this current flows. Suppose here one wire is there and we have one battery, and this is the positive terminal, this is negative terminal. Suppose this is 10-volt battery, you connected with one resistance R. Okay, so actually why current will flow from here? Okay, so this is like this is creating one potential difference of 10 volt. Okay, so creating the potential difference of 10 volts, it's allowing to flow the charge from this from the wire, and it's constitute the current. So we'll know what is current actually. Okay, so I current is Q by T. So Q is the charge, okay, and T is the time. So if net charge Q flows through any cross section of conductor in time T, through the cross section, I will be Q by T. Okay, this is very important formula. You can remember I is equal to Q by T. So what is the Q? Is the charge here. Okay, Q is charge and its unit is, so its SI unit is coulomb, that we represent by C. Okay, so this coulomb one, this is the charge. Okay, charge, this 1 coulomb charge is the charge which is contained in 6 into 10 to the power 18 electrons. 1 coulomb charge. Okay, means this is the number of electrons which contain 1 coulomb charge. Okay, and we know the what is the we know that an electron possesses a negative charge of 1.6 into 10 to the power minus 90 coulomb for 1 electron charge. Okay, so this is the charge of 1 electron. So this already we know. Now what will be the current? 1 ampere current. We can see I is 1 ampere when 1 coulomb of charge is flowing for 1 second. Okay, so if this 1 coulomb of charge is flowing through one cross section for the 1 second, it will give 1 ampere current. So unit of current is ampere. Okay, unit of I current is ampere. Now we'll see one example is there in your NCERT. It is given a current of, so I is given 0.5 ampere. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. So time is given 10 minutes. Okay, 10 minutes. Find the amount of electric charge that flows through the circuit. Now it is asking find the Q. What will be the Q? Okay, so I is already given 0.5, time is 10 minutes. So this 10 minutes we can convert into second, so that is 600 second. Now we already know I is equal to Q by T. We have I, we have T, we need to find the Q, that is I into T, and Q equal to I is 0.5 into time is 600. So it will become 300. And what is the unit of Q? Charge unit is coulomb. So we got 300 coulomb. Okay. Now we'll learn the electric potential. Okay, what is the potential and what is the potential difference? So what is the potential actually here? So why charge is flowing through the wire? Okay, potential difference. So what makes the electric charge to flow through the wire? Okay, so how it is flowing actually? Because of the potential difference. Okay, when we are you put one battery, okay, that is of the, suppose some 5 volt is there, here is the resistance, so it is giving the potential difference here. Okay, positive and negative, there is a difference of potential that only allowing to flow the charge, and which is constituting the current through this wire. So what is the potential difference between 2 points? So whatever we are giving the battery, that is creating the potential difference. So potential difference between 2 points, you can write here, potential difference between 2 points, okay, equal to work done. Whatever work done to move the charge divided by per charge, means Q. Okay, so V is equal to W by Q. So this is the one formula. V is equal to W by Q. So what is the unit of voltage? Is volt unit. Okay, so now we'll solve the question. One example is there, 12.12. okay, how much work is done in moving the charge means Q of 2 coulomb across 2 points having potential difference B is equal to 12 volt. So it is given it is asking how much work is done in moving the 2 coulomb of charge across the 2 points having potential difference 12 volt. So we already know W is equal to V into Q. Okay, and it is asking for the W only. So what is the V? 12 volt. What is the charge? 2 coulomb. So work, this is the work, right? Work unit will be joule, that we represent as J. So W is equal to 12 into 2, that is 24 joule. Okay, so now after that so now we'll see the Ohm's law. Okay, so according to Ohm's law, current flowing through a electric wire is directly proportional to the potential difference across that wire at constant temperature. This is very important. You should must mention the constant temperature factor. Okay, so according to Ohm's law, whatever current is flowing through a metallic wire is directly proportional to the potential difference V across the ends, provided its temperature constant. This is called Ohm's law. So I is directly proportional to V, or V is directly proportional to I. Okay, so if I will bring I this side, it will become V by I equal to some constant. Okay, so this constant will put R, so V equal to I into R. So this is a Ohm's law proof. Okay, so we'll solve some question of the Ohm's law. What and all factor on which there is one important things, factors on which the resistance of a conductor depends. Okay, so on what and all factor one resistance of a conductor depends. So resistance is directly proportional to length Okay, length of the wire, suppose one wire of length L, so resistance will be directly proportional to the length. Okay, and then resistance is inversely proportional to area of that cross section, that wire, what is the area, for that area it will be inversely proportional. So this proportionality constant, if we'll remove, will keep here are rho L by A. Okay, so this rho is the resistivity that we say rho constant proportional, and it is a resistivity. The SI unit will be ohm meter. Okay, you can find this one R into, suppose this one is the R. Okay, A will go this side, this is area divided by length. So resistance, what is the unit of resistance? Ohm, and area is length into length, that is meter square. Okay, and down again length, that is meter. So 1 meter will remove ohm meter. You can prove it by here, this one you can find. Okay, so this is proved. Now in the next video we will learn the resistance concept. Okay, resistance when it is added in the series, what will be the voltage across the resistance, what will be the current, if it is in the parallel what will be the voltage, and how we should add the resistance if it is in the series, and all the basic concept we will learn, and I will give you the tricks also. So please watch the next video for resistance, parallel and series resistance. Okay, thanks.